So last lesson we learned about our rainforest ecosystems and the dynamics and how organisms live within these ecosystems. We learned about one way in which they interact and what kind of link was that. Does anyone remember that?
Food chains?
Yeah, so a food chain is where one organism eats another organism which eats another organism. It's linear, it works in a straight line. So now we talk about food webs, we're talking about like a spider web. And you imagine how all the dots are connected, which connects all the organisms within this one ecosystem. So, we start off with producers. They start at the bottom. So, here we've got producers, or we can call them autotrophs, because does anyone know why we call them autotrophs? Yeah? No?
Because they reproduce automatically?
No, it's nothing about reproduction. It's how they consume. So they create their own food. So we have heterotrophs, which collect food and consume food, and autotrophs, which create their own.
Have you got an example?
Yeah, so we've got producers like green plants. And does anyone know what the autotrophic process is?
Photosynthesis?
Yeah, so photosynthesis is where plants turn sunlight into energy, so sugars, glucose. And that's really where all the energy starts, from the sun. It transfers into the plants, and then we continue. So now we've been learning about the rainforests and what we see around us in the school. Can anyone give us some examples of producers?
Seagrass.
Yep, so we've been learning about the marine system, and seagrass is a producer. We've also got things like eucalyptus, and now we can start to see maybe the next stage of a food web. We've got seagrass, like Patrick said, and the native wattle. So the wattle is another kind of consumer, but it's not the leaf that's being eaten, it's the pollen which is being used by the bee, and that's how the bee creates its food. So the wattle is still a producer. We consume a lot of producers in our day-to-day. What do you eat? What do you think you eat at home, which could be considered a producer? What's green?
Lettuce.
Yeah, so lettuce, all your salads, fruit, vegetables, all that sort of stuff gets its energy from the sun, and then we get our energy from it. So in the next stage of the food web interactions, we're going to the consumers. So they're heterotrophs. So, Pat, get off your phone, mate. Come on. If I have to ask you again, it'll go up on the desk. So consumers, they're the heterotrophs. We talked about those before. They go out and they get food. They don't take it from the sun. They have to consume. So they must feed on other organisms to survive, on both producers and consumers, lower down the food chain. And all consumers must eat all other organisms to survive. However, they're not all predators like your lions and your tigers. They can be things like a koala. We can classify these consumers into two levels. So, does anyone know what kind of consumers we have?
Animals and plants?
No, so plants aren't consumers. Plants are producers because they get their energy from the sun. I'll go through and give you a hint, there's three of them.
Animals?
Once I give you the first one, you might be able to make some assumptions on what the second one's. Nah, not mammals. Now we're talking about taxonomy, and we're going into, that's a whole another side of biology. But we go into herbivores.
Carnivores and omnivores.
Yep, so that's correct. You've got your herbivores, your carnivores, and your omnivores. Herbivores are primary consumers, meaning they only eat, what's a herbivore? Yeah, plants. So they only eat producers. They don't eat animals to get their energy. They only rely on things that are photosynthesized. Then we go into the carnivores. So your carnivores, Mia, do you know what a carnivore eats?
Meat.
Yeah, it eats meat. It eats meat. And what is meat? Meat's another.
Animal.
Yep. So it relies on animals that have got their energy from somewhere else to survive. we've got our last one. There's something funny. But we've got our last one, which are omnivores. And omnivores are considered tertiary consumers, meaning they eat both plants and animals. We've got a monkey there that's an omnivore. Girls. Alright, Monique, can you think of another omnivore?
Like an animal.
Mia, can you think of one?
Me.
Yeah, well done. So you're an omnivore, because what do you eat at home?
Meat and vegetables.
Meat and vegetables, yeah. So that's where we fall into the food web. If we look at the Earth as an ecosystem, we're tertiary consumers. And we move on to our third interaction in the food web, which is decomposers. So decomposers are organisms that get their energy by chemically decaying or chemically breaking down the remains of organisms. So when something dies, what are the things that disintegrate it, that turn it into, what happens when we die? What happens when leaves fall onto a rainforest canopy?
We rot.
We rot. But does anyone know the organisms that give us bacteria? So yeah, bacteria are a decomposer. Well done. We've got fungi as another one. So they're considered nature's recyclers. They turn things that were once living into energy and use it to survive. The leftover materials like water, CO2 and minerals can be reused by producers. So it's this whole cycle. We see the plants get their energy from the sun. Primary consumers eat the producers. Secondary and tertiary consumers then eat all the primary consumers and the producers. That's where they get their energy from. And then once everything dies, whether it's a producer or a consumer, it's decomposed, the minerals go back into the soil, and what uses the minerals in the soil?
Plants.
Plants, our producers. So can you see how this energy is transferred throughout the whole food web? And we have all these interactions between the organisms.
It's all recycled.
Yeah, it's all recycled. It's a consistently moving and interacting system. And that happens on a large scale, a macro scale, and it also happens on a micro scale. So we can see these relationships happen in rainforests, in oceans, in your compost bin. We've got bugs eating decaying matter. There's bugs that are dying. There's bacteria. They're breaking down the veggie scraps and they're breaking down the dead bugs. And then we might have small plants growing out of that compost that are using the byproduct material from these decomposers. So like we said before, these common decomposers are your bacteria, fungi, and some protists, some single-cell organisms, but these are your main two, your bacteria and your fungi. And it makes sense. Where do you usually see fungi? Where do you see mushrooms growing?
In compost.
In compost.
Damp, moist, low.
Moist, low, yeah, areas where dead matter falls, and they can use this energy source. Where do we go from here? So these are the interactions, and interactions exist between all organisms at all levels of the food web. We've pretty much gone through this. You've got your producers, your consumers, and your decomposers, and they're all linked in so many different ways. So I'm going to play this video. Anyone see The Lion King? Yeah. Well, Mufasa here, he's going to explain it to you. I'm just going to have to figure that one out.
Everything you see exists together in a delicate balance. As king, you need to understand that balance and respect all the creatures, from the crawling ant to the leaping antelope.
Dad, don't we eat the antelope?
Yes, Simba, but let me explain. When we die, our bodies become the grass,
So Mufasa just said, explain in 30 seconds what, it took me 10 minutes to explain, but I hope now you've got a really good grasp of all these interactions within a food web. And what we're going to do is we're going to take the task from last week of collecting all the organisms that we saw out in the rainforest, and I've printed them out on some little cards here. And in groups of 2, you're going to divide these organisms up, and I'm going to grab you some wool, and we're going to connect them and make our own food webs that we can then share and explain to the rest of the class. So I want to see the links between your consumers, your producers, your decomposers, and we're going to colour code them. Okay, so if you guys can get to work on that, if you need a hand, give me a yell.
Is that why there's global warming? Because you've got all this input from the sun and then everything getting perfectly recycled. Would there not be an overload of energy?
No, energy is used.
But you're saying it's emitted in CO2, which is then incorporated into the oceans, which is then incorporated into
So-
animals.
You got me confused. Good question. That
No,
would really
so
stack
where do you,
him up.
what's petrol made out of?
Petroleum.
Yeah, what's another word for petrol?
Oil,
Or,
Gases.
oil, or gases, what's another word that we group those as?
combustible.
No, it's a fossil fuel. So we get that petrol by digging up
Decomposed.
things, this CO2, and which is then transferred into a carbon, which is compressed and stored in the ground. We're digging up and burning it. So we're creating global warming by taking this carbon that's been stored by decomposers deep underground and putting it into the atmosphere. It's down there and it's safe. It doesn't need to come out. And the same goes for the seafloor. Does anyone else have any questions? Yeah? No?
Where does water come into it?
Water?
Yeah.
So water is one of the factors that plants use to photosynthesize. So it's a bit more complicated than this, but water plus sunlight, plants can utilize that to create sugars. So that's why we need water, and water is also, all other organisms require water to survive for their internal chemical processes.
Do we in turn then, are we technically losing water then?
No,
So it doesn't get stored like carbon?
No, it doesn't get stored by carbon. Water goes through a cycle. We would have learned about this cycle probably last year. Yeah, you can remember the water cycle
Do you
now.
know what
But
you are drinking
Guys,
water that
guys.
dinosaurs pee in?
Yeah, water memory, all that sort of stuff. That's for another day. We don't need
That's
to talk
true.
about that.
It gets recycled.
I'd like you to start on this task. We can have a class discussion after if we have time about these other theories, but today we're doing food webs and interactions. So get on with that and we'll move forward.